Hello, everyone. Thanks for joining us for this webinar about uplink and downlink capabilities. We today are joined with by three esteemed panelists. Matt Mangriotis, who is the Global Director of Product Management of our point-to-multipoint 450 product line. Dave Geithner, who is our Technical Manager, covering our global team of region technical managers, and Lucia Valbanesi, who is our Senior Development Engineer of the PMP 450. This webinar is being recorded and we will post it to the Cambium Networks community afterwards. But this is one of my favorite formats because what we can do is just have a roundtable discussion about a particular topic. And if you have any questions that you would like to ask, you're more than welcome to participate. Just use the question and answer dialog box on the right-hand side of your screen. Post your question. I'll be able to read it to the panelists. And if there's some individual that you want to direct your question to, just let us know and we will be sure to do that. Well, thanks for joining us. And a couple of things about uplink and downlink. When you take a look at the wireless broadband solutions that Cambium Networks provides, what you'll see is the network can be composed of point-to-point backhaul links, point-to-multipoint wireless distribution links, and also Wi-Fi indoor and outdoor access points to provide coverage. These are always controlled through a central location via the cloud in CN Maestro or our XMS system. And what we hope you can do is design wireless connectivity solutions that support both business and residential customers. Well, one of the things that's happened since the COVID virus, in addition to the parade going by my window right now, honking their horns, is that a lot of people are working from home rather than the office. And one of the things that I'd like to pose to our panelists is, obviously people talk about speed, and speed is critically important, but how do you break down the difference or the value between uplink and downlink speed?
So I can take this question. We can start talking about the frame structure in the 450 line of products. It's a TDD product, meaning that it's using the same channel for both downlink transmission and uplink transmission. And you as an operator can decide the portion of the time that you want to dedicate to the downlink versus the uplink. This is the duty cycle, the downlink data percentage. It's one of the parameters in the GUI that you can set, and essentially decides how many of the symbols, how many of the time you dedicate in transmitting in the downlink versus the uplink. Well, there is no right or wrong answer, but the way you would set this parameter really depends on the type of traffic you expect in your network. If you expect that people would download a lot of information, then obviously you want the downlink time to be longer. But if you expect more traffic to be bi-directional, say for example now, like you were saying, many people join conference calls from home, and now they have a video going in both directions. Now the traffic is more uniform in both directions. It's not just downloading information. So in that sense, now you have to look at your uplink capacity as well, if it can keep up with the downlink. So depending on the type of traffic you expect in your network, that's the input in your decision on how to set the duty cycle in the frame.
And just to further add to Lucia's comments, this is Matt speaking. Our system, the 450 system in particular, as well as ePMP, is more scalable in terms of duty cycle, meaning you can actually modify that duty cycle in a lot of different ways to optimize your system for these changes that occur in the network. I mean, historically with residential broadband, you're setting this to a very heavy downlink setting in order to provide that downlink to those end users. But as Lucia mentioned, and as we have this crisis evolving, more and more folks are working from home and require more uplink. Therefore, the ease of the changing of that frame structure is evident in both 450 and ePMP, all of our point-to-multipoint platforms, in order to better serve the customer base. And you can continue to optimize that as things evolve and as things change. It's far easier. There's more options, and there's some settings we can talk you through if need be, that can optimize that for you. And when compared to other technologies, just want to put a plug in there for what we've done here at Cambium. We have a purpose-built software-defined radio system in the 450 platform that is far more flexible in terms of frame structure than anything else that's out there, and it can service that uplink channel in a much better way than some of the competing technologies, especially things like standardized mobile technology like LTE. We fare better in the uplink when compared against that.
Well, that's a great point, Matt. I guess one of the distinctions, and I appreciate the fact that it's tunable and that those settings can be modified. Can you modify those settings, or when somebody does modify the settings, is that network wide, or how granular is that?
It can be site to site, but it also might impact the timing. And one of the hallmarks of the Cambium systems has always been the synchronization aspect, which allows you to minimize self-interference. So when your networks are synchronized, and as Lucia mentioned, it's a TDD system. So you're transmitting in part of the frame, and then you're receiving in part of the frame. Every radio does that. And to be fully optimized, you want to be synchronized across your entire network, at least in the fact when sites can hear each other. So if you have an isolated part of your network that can't hear other sites, then no worries. You can change the duty cycle as needed on a case-by-case basis. But when those are within earshot or within range of other sites, you want to make sure that your entire network is synchronized and in order to minimize that self-interference and optimally perform. Further, you can synchronize, it's so flexible that you can synchronize with other technologies in the area as well. And I think that's another key point to our proprietary purpose-built platform, is that we can synchronize with those standards-based platforms when they are within earshot or within range and utilizing the same frequencies. So that's another a benefit of using Cambium technology for this.
And to help you decide how to change the parameters, we do offer a colocation tool where you can input the parameters, for example, of a nearby site, and then you can see how the frame timing is affected if you want to change the duty cycle only on one sector, for example, or in one area of your network. The configuration parameters don't have to be the same across the network, but they have to be compatible. So the colocation tool is helping you in seeing if two sets of parameters can go together, meaning that if there is no case where the void access point is transmitting when the other one is receiving, or vice versa. So with the colocation tool, you can see graphically, it displays the frames, so you can see where the downlink and the uplink is. And also it has two equations, two checks, essentially, to make sure that there is no talk over the other system. So you can play with it. And the good thing is that the duty cycle has a 1% granularity. So you really have a lot of flexibility here in terms of making sure you can collocate and you give enough uplink. And this is very useful if you want a little bit more uplink, but you don't want to go from a 75-25 to a 50-50, for example. With a 1% granularity, you can pick anything in between and the frame will adjust accordingly.
Well, that's great. And where can I guess a network operator get a hold of the colocation tool? And everybody's going to ask, how much is it?
Oh, it's free. It's on the Cambium support site.
Great.
And we can share, maybe after this, we can share a link to it if people need a pointer to it.
Great. And thanks, Chris, for posting in your question. And I'll throw this out to our panel here. Can you discuss the consideration for high priority uplink traffic as it relates to MU-MIMO grouping?
Okay, so by default, the mu-MIMO grouping groups the low priority and the medium priority traffic. But you can configure it in the 450M AP to group all the traffic levels, all the QoS levels if you want to. It's a delicate balance, because from one point of view, you want as much traffic as possible being grouped, but at the same time, if it's the higher priority traffic, you don't want that to be queued up to wait for the group to be built. So in general, it's better to leave the high priority traffic ungrouped, so that as soon as it arrives at the AP, it gets scheduled and it's out of the way, if you wish, but it's scheduled in single user MIMO. And then the lower priority, medium priority traffic can be queued up and form the bigger groups. So now you have a better mu-MIMO traffic at that point. There is another aspect to consider when, I don't want to go into too much of the details of the scheduler, but when a scheduler forms a group, it takes one of these QoS levels to be grouped with others from other SMs that have enough spatial distance between each other. If you don't have a lot of data to send, you can still use this level to be grouped with the others. But then what happens is that the data is repeated within the number of symbols you have allocated for the frame, because you only had data for a few symbols, but the group occupies more time. Now, in the higher priority traffic, typically you have a lower amount of data. So if you decide to group these quality of service levels, these VCs, together with the others, then it's more likely that your multiplexing gain is going to be low, because now you are creating a group with 3, 4, 5 VCs, but some of them may not have enough data to completely fill the frame or the portion of the frame that's allocated to the group. So your efficiency goes down a little. Again, there is no right or wrong answer. If you do decide to group it, is not wrong, but some things to keep in mind, that the efficiency may go down a little. If you had other data that, the lower priority queues were longer, you would have been better off grouping those, because then you could have pushed more data through the mu-MIMO group.
Well, that's good, because that shows exactly how a network operator can groom and tailor the network to meet the specific needs of their customers, whether they're at work, whether they're at home, or whether they're working from home. But how can a network operator get started? Let's say if you don't have deep experience in this, where would you start to look for information to figure out whether you need to make any changes, whether that's worthwhile, or whether your network is performing just fine?
Well, I would say definitely a good starting point is to look at the frame utilization statistics. They are broken down per downlink and uplink, and it gives you an idea how the frame is used in time. The consideration is slightly different with mu-MIMO, with the 450M, just because it has two dimensions, if you wish, for scheduling. It is the time dimension and the grouping dimension. But the frame utilization gives you an idea if you are completely using your uplink, for example, you're always 100% utilization. That's definitely a signal that you may want to adjust your duty cycle.
Great. And I'd appreciate it, anybody in the audience, if you could just share your experiences on what you're seeing as far as data usage from the field or uplink and downlink performance. That would be great. One of the other tools that we have is the capacity planner, and I guess could you just give an overview of what that is and how people can use that?
Sure. So it's an Excel spreadsheet where you can put information on a certain configuration for your sector, and it gives you a theoretical performance of what you would expect in that sector. So it's very useful for kind of a what-if scenario to understand what kind of throughput you could get in certain deployment scenarios. There is a section at the top where you input all your parameters. So you indicate which type of device you have, if it's a 450M, a 450i. You can select your region, your frequency band, and all the internal parameters are accounted for. So the tool already knows this device in this band is going to use this much transmit power, for example. There are options for all the antennas that we support. You can pick one from the drop-down menu, or if you're using a connectorized device with a third-party antenna, you can just specify your cable loss, your antenna gain, and the tool will take that information as well. You are going to indicate your channel bandwidth, your frame length, if there is interference in the area, and all the inputs for the calculation. Then you're going to select a type of subscriber that you're considering for the area, and then the tool is going to calculate the average capacity for that sector given a certain distance. So for example, you can decide I only need to cover 1 mile versus I need to cover 5 miles or 10 miles. So it's going to give you an idea at this distance, how many subscribers will I have at each modulation level? And given that, what's the average expected capacity I can have in the downlink and in the uplink? The tool has different tabs. So this one I described is the first one. The second one, you can dig a little deeper, meaning that it gives you the opportunity of indicating a mix of subscribers in the sector. You could have some mid gain 450Bs or some high gain. So you have some 450 SMs. So you can indicate the percentage of the subscribers, and it takes that into account, because clearly each one is going to have a different antenna gain, possibly different transmit power. So all of that is taken into account in the calculation. In the second tab, you can also input the type of plans you're offering to your customers, and it's giving you an idea on average how many customers you can support with those plans with a certain distribution. Obviously, there are some assumptions. The assumptions is that the subscribers are evenly distributed in the sector, and that they're all generating the same amount of traffic, which may or may not be true. I mean, in a typical sector, you may have some subscribers that are way more active than others, but the tool is giving you an average view of what to expect in these cases. And the duty cycle, the parameter we are discussing here, it's one of the inputs. So you can also adjust that, and you can see how the downlink and uplink throughput will adjust accordingly. So you can see an estimate. If I move my duty cycle by 5%, what's the effect on my downlink throughput and my uplink throughput?
Thank you, Lucia. And I know that we've now been in quarantine, at least here in Illinois, for about 6 weeks. And I know that each of the three of you have had a chance to talk with network operators, not only from the United States, but from around the world. I guess if each of you could just kind of go around and just say, what would you say would be probably one best practice that any network operator can use to optimize their network, that would be very helpful for the audience.
Well, I think we started out by saying things about duty cycle, and I think that is an important factor to look at. There are ways to optimize that to better serve your clients if you're a network operator, especially in the days of Zoom meetings and Google Hangouts or Google Meets. There's all kinds of uplink traffic that needs to be accounted for, that's easily accommodated by that duty cycle. So evaluating that first and foremost, and you can do that through the statistics that we provide called uplink frame utilization, as well as others statistics that can be measured in the radio system. So that's a best practices to help evaluate that by pulling those statistics as often as necessary to especially during the busier hours, which is typically the afternoon hours now rather than the evening hours. But that's something we've seen a lot of customers doing.
Thanks, Matt. Lucia, Dave?
Yeah, so many questions I receive is also, how do I understand when my access point is at capacity? And this mostly comes for the operators that are using 450M, because it's less straightforward than the 450 or the 450i. So definitely using the frame utilization, like Matt was saying, in the uplink gives us visibility if we are reaching capacity. With the 450M, you need to understand how to put together more statistics to kind of get the full picture, because the device can completely utilize the time, but you may still have spare capacity in in the grouping direction. And that's important to understand that you're definitely not the capacity if you're using all the time, but for example, your multiplexing gain is 1 and you're never grouping, it means you don't have enough traffic to group. So clearly there is spare capacity there. So things I would recommend is don't only look at the frame utilization for Medusa for a 450M, look at the average group size, at the multiplexing gain. This gives you an idea of how many subscribers you can group on average. And also the heat maps in Medusa are very useful because they give you a view over time. Many of the statistics we show are for a minute, 5 minutes, 15 minutes, but the heat map gives you a view over an hour. And you can see all the spatial directions over time. You can see the color codes. If you see areas with more yellows and reds, it means it's very busy. If you see areas with more like blues and greens, it's not busy. And you can see if you have some directions where it's always busy, always congested, that's something to keep an eye out on. Do you have the possibility, for example, of moving some of these SMs to another access point? If you have the possibility, if the SM sees multiple access points, if you see congestion in one direction, what actions can you take to alleviate it? Like I said, maybe moving it to another sector. But if you see that you still have spare capacity in many directions, then you know you're not at capacity yet.
Great, thanks, Lucia. Dave Geithner, did you have anything that you wanted to add?
All right, what, can you hear me all right?
Yeah.
Sure, so a couple different things. Obviously the things that Matt and Lucia have just conveyed about looking at frame statistics and things of that nature to kind of determine are you at capacity or not are definitely probably the key things. Although one of the things, well, a couple things to make the attendees aware of. There was just recently, Cambium just recently had within the last couple of weeks a webinar that we can probably link to this one here on specifically talking about 450M capacity and how to kind of drill down into various different things that we provide within the GUI of the radios to help operators understand, not just looking at the statistics of what's my frame utilization look like, but things even before that. What is the modulation levels of all the devices that I'm doing, and are any of my devices, my subscriber modules or CPEs that are on my access points really struggling and perhaps impacting the available capacity overall to the network, instead of just immediately going and adjusting my uplink or downlink ratio? You may want to take a couple steps back and kind of observe a little bit more of the health of the overall sector to determine, is there other things perhaps that are impacting my capacity indirectly before I just go and start tweaking my uplink or downlink ratio. So we provide a lot of things like link quality indicators, bit error rate assessments, link tests, things of that nature to kind of overall gauge how efficient are all of the CPEs or SMs that are attached to my AP working. And you really want to focus on that to try to get all of those things operating very well. And then you might be very amazed that you see a access point that previously was kind of looking like it was pegging out on either its uplink or downlink statistics during a busy hour, or trending through a whole busy hour scenario or a whole busy evening. But now you might see it come down a little bit because you've optimized a lot of your SMs, whether that was through adding some kind of antenna augmentation with adding a dish or changing out to a higher gain antenna type of device, or whether there was some interference that you could mitigate in some way with a higher gain, narrower band antenna, things like that. So I guess the point being is I want to make sure our listeners kind of walk away with not just immediately, if you're running into capacity issues, run to that duty cycle modification area, and you can tweak on that, which is very flexible, and there's some good tools out there that we just got to tell you about. But maybe take a little bit of time to kind of look at the overall health of the AP and some other areas that might be dragging down some of the capacity of that sector, optimize that, and then determine, do you need to make some kind of other adjustments within the duty cycle.
Great, thanks, Dave. And one question came in from Chris, and that was, can you discuss the proportional scheduler feature and when to use it, or when is it not right to use it?
Okay, good question. So the proportional scheduler feature has a different strategy when it comes to scheduling. Essentially, the idea is when things get congested with the proportional scheduler feature, you allocate bandwidth to the subscribers in proportion to what their original plan was. And this is different behavior from the legacy scheduler, because when in that case, when things got congested, essentially it ended up being a kind of a round robin scheduler, and you lost essentially the indication of which subscribers had the higher plan. So the proportional scheduler is built on this concept of plans. You can give a weight also to the plan for a subscriber. If, for some, you want to guarantee that they're going to get more bandwidth even when things are congested, then you can play with the weight. There are additional parameters that you can use. For example, if you want the proportional scheduler to only kick in below or above a certain threshold, or if you want the plan to be honored only at a certain modulation. So there is a lot of flexibility there in how to configure it. But that's the main difference, essentially, that everything comes down to the plan you have defined for the SMs, and the scheduler will honor the plans no matter what, even things get congested. So if you configured one SM with 5 megabits per second plan and the other one with a 10, if you don't have enough bandwidth to serve both of them with everything else, then they both will get less, but the one that had twice the plan will always get twice the throughput, essentially. So it really depends on what you're trying to achieve, and if you have all SMs on a similar plan, or if you have some that you really need to guarantee the bandwidth to, then you can play with one scheduler and the other and all the parameters. So it really depends on the mix of customers that you have in your network.
Great, thank you, Lucia. Thank you, Dave. Thanks, Matt. This has been very informative, and obviously if folks have other questions or experiences that you'd like to share, you're welcome to do that on the Cambium Networks community at community.cambiumnetworks.com, and that information is all free, and we will be recording this webinar and posting it there sometime this afternoon. So we wish you and your families all very well through the pandemic, and look forward to continuing to help you connect the unconnected. Thanks, everybody. Bye.